Okay, it's 9 p.m. Japan time. I'm gonna get started. Yeah, it's around time. Okay, hello. This is Junichiro Horikawa, and this is the 36th live tutorial for Houdini that I have been doing weekly. And the topic today is to create a simple agent system called as a swarm intelligence. And just creating a agent system is not that fun, so I have also implemented some collision detection between agents. So when different types of agent met together, in this case I made two types of agents. One is prey, one is predator, and when predator tries to catch those preys fleeing from the predators, and when those predators catches preys, I have created an effect to launch or launch this kind of fireworks. So that's the things that I would show you how I could do that. Typically, I'm going to start by creating a basic flock system based on the Boyd system, I think being explained by the Reynolds. Then going to extend that system so that I could have this kind of a collision effect between different agents. So that's what I want to do here in Houdini. And I don't think the version doesn't really matter for Houdini. I'm mostly using Vex in order to achieve this. So I think even using Houdini 16 would work in this case. Alright, so let's see. Let's just create it from scratch. First thing we need is to create a basic system for the swarm intelligence, meaning a flock system. So let me do that first. To get started, I'm going to first create a boundary geometry. Could be any kind of geometry. I mean, in a lot of cases when people create flock system, they create a box shape. But since we're dealing with the 3D software, let's just create some other geometries, like starting with sphere, but could also be any kind of geometry. And let me just delete this. Okay, I'm not sure if my voice is going out. Well, hopefully yes. Okay, and starting from creating a sphere, polygon, it doesn't really matter what the frequency is, but making it high frequency will be able to create a high res normal direction, so I would prefer that. Okay, and let's see, first of all I'm going to place a normal node to this boundary for primitive, which I'm going to use it later on in order to bounce those swarms agents inside the boundary when the agents try and go outside of this sphere. I'm gonna make velocity forces on the opposite direction. Okay, and let's start by creating a base points for the agents. But before doing that, I'm going to explain a basic understanding of a swarm. Right, so first of all, you have those agents treated as a point in Houdini. And each agent has this local rule in order to move themselves. And in a basic rules for flocking, there are 3 rules. One is alignment, one is cohesion, and one is separation. Okay, for the alignment, the alignment force is going to be the force which let those particles which is close to each other facing to the same direction or to the similar direction. So this particle will look at the neighbor points and try to look at the same direction with other agents. So that's the alignment force. Now for the cohesion is the force to let particles get close together like this with some specific cohesion scale and the search radiuses. So each particle again have some search radiuses by itself. Within the radius, this particle will look at those particles which is within the radius and trying to get close to those particles by having the average direction. So for this one and this one, by an average, you get this vector and so on. As a result, all the points will come together to get closed. But if we have only those cohesion forces, then in the end the points will like stuck in the one position. So in order to avoid that, there's another forces which is called as separations. This one is the opposite force of the cohesion. The points try to avoid going too close. So with some specific search radius as well. So having a balance between the cohesion and separation is pretty important. Setting the same value, it doesn't really do anything, but having some kind of balance, maybe the separation is a bit higher than cohesion, or cohesion might be a bit bigger than separation, to have some kind of a to simulate some kind of a crowded swarms. Okay, so combining all those three forces to move those particles will enable you to create a kind of a crowded swarm movement, like a school of fish or like a sheep's and so on, like the one that you see on nature. And this case, in these examples in Houdini, I'm going to make those particles fly on in 3D space freely. So maybe you could think it as a bird, right? Or maybe fish. Okay. And knowing that, first thing I need to do is to create some points inside a sphere, right? Okay, I'm not sure if anybody is watching this. Maybe not, but I will just continue. Maybe I might stop somewhere if I don't see anyone here. Maybe try this out later. Okay, anyway, first thing I would like to do is create some points inside a sphere. So what I could do, I could create a iso offset to create a volume from the geometry first, then create a scatter point, a bunch of points inside this volume. Okay, and let's try to control the number of points by having a null node, name as controller, having all those parameters that I would like to control later on as a parameter, as a global parameter, right? So let's see. In this case, I would like to control the number of points. So let's say number agents. Okay. And let's also give a label to determine, to let people know that this is for the global parameter. Okay, And let's also set the range with between 0 to say 1000 or 10,000. Not sure if this still works. Might be too much, but let's see. I'm gonna start with the small numbers like 100 for testing. It's always better to make it from small to big. Alright, okay. And I might want to control the size of this boundary as well. In this case a sphere, so let's also set the size. But I might want to switch this geometry at some point, so I think I'm gonna keep this sphere as it is. And maybe set the size for this sphere as a constant value, like 4. Okay, now I have a radius of 4 for sphere, and I have 100 points inside the sphere. Now I will start by creating one type of agent, and later on I'm going to create another type of agent so that I could have interaction between two different agents. But to get started, I'm going to start by creating one type of agent now. To do that, first of all, I'm going to create a group and set it for points. Let's set it as agent, right? And also I'm going to create a point wrangle to initialize some of the attribute. Okay, so let's think about what kind of attributes that I need. First thing, since I would like to create a trail for each particle, I'm going to, after calculating the movement using a subsolver, I'm going to use a add node to connect the trail points. So for each trail points, I need some kind of IDs to know which points to connect together. So I'm going to create an attribute called ID as an integer, and for this one I'm just going to apply a point number starting from 0. Okay, and I am also going to create the value called name. Maybe I might use this name instead of ID for connecting the lines. Okay, so for now I'm going to just copy the ID but convert it into a string. Okay, now let's see. And I also, in order for these points to move as initial direction, it's not necessary, but I might want them to move at some random direction on the initial process. So let's create a vector attribute called velocity or vel and make it random for now. So rand at p using position as a seed, and since this is the positive value between 0 to 1 for all x, y, and z, I'm going to subtract this by 0.5 for each of the coordinate. Okay, and let's also normalize this. And I might want to set the speed for the initial velocity as well. Well, let's multiply it by I'm not sure what's the best value for it. Let's just keep it as 1 for now. Okay, and I also would like to set the type for agent, and later I'm going to use the type attribute to determine which type is which to create a collision, to create interactions. So I'm going to create a integer attribute called type, and let's say the first agent that I'm going to create is having a type equal to 1. Right. Now that looks fine. Let me also color these points, and it's a bit hard to see the points since the size is a bit too small. Let's make it a bit bigger. Okay. Now I'm going to create a color node, and I'm only going to apply a color to a type equal to 1, which in this case I only have one type of agents, so it doesn't really matter, but in case we want to add agents later on. Okay, for those points I'm going to set it as blue. Alright, and its point, I don't see any color changes. Let's look at the attribute if I have those points having a attribute that I want. So I have ID, name, and type, all the points have a type equal to 1. Looks good. Now if I set it to color, now, okay, I think I need to change this one. The group type is equal points. Right, now it works. Now let me also change the background to, the material to a bit brighter color, so that I can see it a little better. Okay, I think it's good. Now maybe a little bit lighter. Right, that looks better. Okay, so this is the initial setup for the agent. I think that's enough. Would it? Alright, now next thing I would like to do is to create a solver to actually start creating a basic swarm intelligence system, a flocking system. Which if you are used to those kind of creating artificial life stuff, maybe you have already done it, so you have some image how you can do it. Well, let me just show you how. As a refrain. Okay, so I'm going to connect this sphere, the boundary sphere, to the second input for the subsolver, which is going to be the constant or static geometry. For those agents that I want to move, I'm connecting to the first input. Right. Okay, now let's first create some framework, what to do for each wrangle. Okay, so I'm going to use several wrangles in order to create the agent system. First of all, I'm going to create a basic cohesion, separation, and alignment forces. So alignment, sep, cohesion forces. And then by having all those values, all those forces, next thing I would like to do is to use that force to update the point position. So update point position. And then after updating the positions, sometimes the point might go outside the boundary, so you need to make it bounce when it goes out of the boundary. So I'm going to create a point wrangle called bounce for this input geometry for the boundary. So I'm gonna connect it to the second input, and I think this will be the basic setup, basic framework in order to create a swarm intelligence in subsolver. Right, so let's fill this in. First thing first, we need to create some forces value for alignment, separation, and cohesion in order to control the points, each points. And currently we only have one type of agent, so it's pretty easy to go for. So I'm not gonna filter anything with the group for now. And open up the code editor. And let's start writing some code. Right. Now for cohesion, separation, and alignment, what we need to have is those search radius for all the types of forces. So every alignment, cohesion, separation, you need separate search distance, search radius for the agent. to look for the nearby agents. Okay, so we need to have that as a parameter. Then also we need to have a relative power for alignment, cohesion, separations, meaning like what's the relation of the power between alignment, cohesion, separations? Is it 1 by 1 by 1 or 0.5 by 1 by 2 or something like that? And based on those relation, or based on those ratios, I'm going to control what is bigger, what is more powerful. If cohesion is more powerful than separation, or separation is more powerful than alignment, and so on, that will create a different kind of behaviors for each agent. Okay, and will create a different kind of crowd movement. So let's set that up. Okay, something looking like that. So first, let's create a search radius for a alignment. So ally rad is equal to chf ally rad float sep rad chf sep rad float cohesion rad chf cohesion rad, and for the scale, for the size, alignment scale chf ally scale float sep scale chf sep scale float cohesion scale chf cohesion scale. Right, apply. Let's promote all those parameters. Now we have 6 parameters now. And let's have this set for initial value like 0.5 for all the radius for now, and then for the scale I'm going to set the same value for this one as well, for 1, 1, and 1. Okay, for testing. Okay, so let's start by creating alignment force. Right. So first thing you need to do is, for each agent, I want to look for the nearby agents within this alignment radius. So that could be done by using npts equals to near points function, or PC find. I use this one because that's easier to use. It's from the 0, and the radius, I'm using the current point position as a starting the search distance, searching point. Then the radius, I think I can set the radius for this near points. Let me go to the vex function page and see what kind of parameters I could set for it. Okay, so I could either set point positions, max distance, and also I can set the max points, number of points. There's also options to set the PT group. That might be also useful. Okay, so simply for this one, I would like to search for the point group which has the same type value. So if I add another agent, I don't want to create a cohesion alignment for separations with that different agents. So I want to filter it so that those forces only works with the agents with the same type. So I could start by creating a group expression saying type is equal to I2A my type of myself, right? And the search distance is lyrad, and I could also set the maximum point number to search for, which might be necessary because if I create like tons of 1,000 or 10,000 of points, then making it unlimited will obviously slow down, and it's not really necessary to just get all the points within the radius. So let's say the maximum is 10 for now. I think that's enough. And when you set to 10, I think what you get is the points from the closest points. So that's good enough. Okay, and if you think the calculation is too slow, I think you can reduce this value later on. So maybe I could also parameterize this as well. Max PTS is CHI, max PTS. But not really necessary to promote this as a global, maybe. Okay, I am going to set it as 10. Okay. And replace this with max PTS. Okay, so maybe I should also rename this. Well, I'll just keep it like this. Okay, now next thing I would like to do is since I have just retrieved all the nearest points, which is within the radius with the same type, I'm going to loop through all the points that I have found like this. And first thing we want to do is to calculate the distance between the points and the neighbors, so that I could use the distance to kind of create the affecting values, affecting multiplier. If it's close enough, then the affection of that points is going to be bigger. If it's far enough, then the affection of that point is going to be smaller. So for that purpose, I'm going to first retrieve that point position at that point using point function at npt, right? And let's calculate the distance between those 2 points, one from the current point position and one that I have found on the new point, right? And I could then this distance is in between 0 to this ally rad, which is going to be the maximum distance in this case because all the points is within this radius. So I'm going to convert this value into a value in between 0 to 1 by using a fit function so that it will be easier to use. So distance is currently in between 0 to ally rad and convert it into 1, 0. The reason why I make it 1 when the value is equal to 0 is because I want to make it more powerful for the power when the distance is close enough. Okay, and one thing I forgot to do is that there is a chance that when I use new points with the same type, there's a chance that you get the same point for myself. I mean, the near points array might include the point itself that I'm calculating right now, in processing right now. So I need to exclude that because the distance is going to be 0. So if ptnum is not npt, and I need to make this written before, then I could start calculating the force. Okay, now the thing that I want to do here for the alignment is that if I write in this sketch, so let's say I'm looking at this point right now and there are several points that has been found. Maybe I should make it something like this, and all those points have its initial direction, initial velocity, like, oops, like facing this way, facing this way, facing this way, and facing this way. And what I want to do for the alignment is to pick all those directions which is within the search radius, which is around here. So I want to pick this direction, this direction, this direction, this direction for this point, and add all these vectors together to create one average vector. And I want to use this vector as a acceleration value to update the velocity. So that's what I want to do. And when we add those vectors together, I also want to consider the distance between the points and those nearest point, D1, D2, D3, and D4, and so on. And based on the distance, if it's far enough, then I don't want to make this one get too affected. But if it's close enough like this one, then I want this one to have more powerful, be more affected. So using distance as a ratio, what I want to do is to, let's say this is the vector 1, vector 2, vector 2, vector 3, vector 4. For the final vector that I want is something like d1 v1 divided by d1 plus b2 divided by d2 plus, and so on. So that's the things that I want to do in order to create an averaged vector, the final averaged vector for alignment. Alright, so let's do that. Okay, now to do that, I already have the positions, the neighbor positions, and the current positions. But in this case, what I want to get is the velocity for each point, which is stored as a velocity attribute. So we can retrieve that by using a point function again, using 0 with the val at npt. Right, now this is the function that I want, and the value that I want, and by multiplying this by d, we'll be able to calculate something similar to this one. I'm not dividing by d because I already fit it from 1 to 0, so which is pretty similar to what I have done right here, which is this one. Okay, so now that I have a velocity, what I want to do is to get all those velocity from the neighbors and create the average. So I'm going to create a acceleration value outside the loop, set it as 0 for initial value, and then add those velocity into the acceleration one by one. And after I have updated the acceleration value, maybe for this one, since this is for the alignment, let me name this ally. Okay, ally. And after I have added all the velocities, the length of the acceleration doesn't really matter at this point, so I'm just going to normalize this. What's important here is the direction. So I'm going to normalize this, and after doing it, I am going to create another values, call vector, call ACC, which is an acceleration value, and I'm going to add this alignment, maybe normalized again. Currently it doesn't really matter because I have only one, but later on I'm going to add the separation and cohesion as well. Okay, and later on I'm going to store this as an attribute later on. Now, for now I have just created alignment forces. Maybe I could just test this out using the current points to see how it works without any cohesion and separations. So to do that, I don't really need the relationship between relationship value, because I only have one forces currently. So I'm just gonna assume that the scale, alignment scale, is equal to 1 for now. And what I'm going to do is to create a swarm ACC, create a attribute called swarm ACC, a vector attribute, to store this acceleration value. Now when I do that, I also want to set a speed for this acceleration, the speed per frame. Now currently the size of this ACC is equal to 1, so that's too fast in this space, so I have to reduce the speed, how much it moves in one frame. So I think I also need that attribute. Let's name that speed. Okay, and multiply this ACC with this speed value to store it in a acceleration attribute. Apply. Oops. Okay, I got some errors. Where is that? Variable D 20 T. Okay, this should be F. Okay, now accept. Promote some of the values. So speed, I have the speed. So let's say 0.02 for now. Okay, and now that I have created the acceleration value, I haven't really updated the position yet. So I need to use this acceleration value that I have just created somehow to update the positions. And this update position wrangle, point wrangle, is the one that I'm going to do that. So let's do that. Going into the point wrangle, and I might need to filter this group. Let's say agent. Okay, and for this one, maybe I can also filter it with agent for now. Although there are only agent points, so it doesn't really matter for now, but later on it's going to be effective. Okay, now I have this max speed. First of all, I'm going to retrieve the velocity, the acceleration value, and add those acceleration value to the current velocity for each point, so that it works as the Newton's law. Okay, so the current velocity is v at vel, and you can add the acceleration value that I have created in this ali-sep core forces node by accessing to the what's the name? Agent, swarm ACC. Okay. Currently, there's only one alignment, one type of force, which is alignment, is applied to this swarm ACC. Okay, now when I have updated the velocity, next thing I would like to do is to update the position using this velocity. Now there is a bit of problem with here, because I'm constantly adding this accelerations to the velocity at each frame, so at some point the speed of this velocity becomes too fast, makes it go off to the space somewhere really fast. So let's check that out. If I play it, wow, yeah, as you can see, it just goes too fast. So you need to have some functions to limit the speed of the final velocity, and I'm going to do that by setting some clamp value and maximum values for the speed. So let's create the parameter called max speed and use this as a maximum speed value. Let's say 0.1 for now. Maybe that's too fast, but let's just see. And I want to reduce the speed of this velocity that I have updated when the length of the vector is more than 0.1 right here. So what I could do, there might be a better way to do this, but what I could do is to first check the length of this velocity. If it's bigger than the max speed, if so, then I'm going to update the velocity's size by first normalizing it, then multiply by max speed, so that the speed will be clamped with this maximum speed. Okay, now let's see again, going outside the solver, and if I play it, now the speed problem seems to go fine now, although I don't really see if there's a alignment forces working or not. Maybe that is because the distance between the points is too far for the searches. So let's try to make the search value for the alignment a bit bigger to just test out. So let's say 10 for alignment radius. Okay, and if I play it, now you can see that all those points are aligning to the same direction, and I have just proved that this alignment function, it works. Okay, now if I set it to 3, I might have a bit more. Well, I think it's working. Now for now, there's just one alignment force, so the result isn't that interesting. It doesn't look really natural, doesn't look really organic. So in order to make it more like a creature or life, artificial life, you need cohesion and separation as well. So let's also create that forces, right? Okay, so to do that, what I'm going to do is to go back to the alignment sep cohesion forces node right here, and basically I'm going to copy those code for align forces, and I'm going to rename this to separation, or maybe cohesion for now. Let's start by cohesion. Okay, and let's rename this to core and core. Okay, and also replace this align_rad with the co_rad cohesion radius. Other than that, I think it's fine for the near points. This is also fine. This is also fine. It's fine. Calculating the distance is also fine until here. And this is the place where I could change for this one. Now for the velocity, this time I don't need to check for the other points velocity, but what I want to check now for the cohesion is to check to create the directional vector from a current point to the near point. So in this case, if you're looking at the points like this, and there's a neighbor points like these, maybe you just create those. What I want to do is to create a vector going from the current points to all those neighbors. B1, B2, B3, and so on. And the final vector will be B1 plus B2 plus B3 and so on. And for this one as well, I'm going to consider the distance between the points, those 2 points. So I'm going to do the same things like I did for the alignment, dividing those vectors with the distance. Okay, and as a result, you'll be able to get a final vector going to the average direction. Okay, so that's what I want to do here for the cohesion. So let's do that. Okay, going back to the code. And so this is not necessary anymore. I'm going to create a new velocity value, which it can be calculated by subtracting the neighbor position, which is npos. Subtracted by current position will create a directional vector from the current point to a npos, which is a near point position. I'm going to normalize this as well and multiply it by f like I did for the alignment. Okay, so apply. Okay, I got some errors again. Where is it? Multiple declaration of variable in PTS. Okay, I guess I am using the same variable name, so I'm going to just delete int, and then should it work? Nope, still not. Errors warning encountered during Vex compile. Empty array index. Okay, where is that error? 28. Okay. I think I don't need this square bracket. Okay. Alright, now this should work. Now I have just created the cohesion, but I need to normalize this cohesion. Okay, so next thing I'd like to do is to add the cohesion value that I have just created to this ACC and normalize it. And then after making, so this means that I'm retrieving the normalized or average direction between the alignment and cohesion and make it as the final direction for the force. Okay, and after having more than two forces, you need to consider the relationship, the ratio for each powers. So what I can do is to multiply this alignment by light scale, and for the cohesion I can multiply with cohesion scale, so that I can control the ratio between two different forces. Okay, but in the end it's going to be normalized, so just the direction will be considered, and finally the acceleration will be multiplied by the speed to have the final acceleration value. Okay, now let's check this out. Going back again to the parameter, let's say the alignment radius is 2 and the cohesion radius is 1, and let the scale be 1 for all of them, and let's test it out to see what happens. And I'm not sure if the cohesion is working. Let's set the radius for the cohesion a bit bigger, like 3. Okay, and let's see. Now you can see that some of the points has been gathered together, so I think the cohesion forces is working correctly. So when the points are found in the radius of 3, the points get attracted to each other like this. Okay, seems good. Now as you can see, when you have only the cohesion forces, the points just gather to the single point position, so that's not really what we want. But we want to have some kind of separation distance between those points, at least several distance. So to do that, we need to have another forces, which is the separation. Okay, so let's do that again. It's pretty easy for the separation. It's pretty similar to what the cohesion force. I'm just going to copy it, rename this separation force. I'm going to rename this to seprad. This is okay, this is okay, this is okay, and should change this to seprad. Wait, I think I need to replace this to cohrad. Forgot to do that. Okay, and I'm going to replace this with separation. This one as well. What else? That's it. Yeah, separation to think so. And the things that you need to change here is the direction of the vector, because in this case you want to go away from the neighbors, using the separation forces. And so to do that, you need to make the subtraction order backward. So add p minus and pos will just do the job. Okay, so let's see if I have all the set up correctly. I think so. Now what you can do is to add this separation together with other forces. So sep multiply by sep scale. Right, and that's it. Oops, I'm missing some parentheses somewhere. 43, 43, around here. Okay, I'm missing a comma right here. Okay, let's test this out. Let's set the parameter for the separation radius to 1 or 0.5 or maybe 1. Okay, and set the scale for 1 for everything. I'm going outside the solver and play it. Now, as you can see, the point is having a kind of a small distance between each other, not connecting as a single point, but still moving as a crowd. Alright, so looks good. So this is the basic setup for the swarm intelligence or agent-based system, or flocking system maybe. And after having this setup, what I need to have next is obviously the boundary setup, because right now, as you can see, the bird, all those agents are flying away from the center and just go forever. So I would like to set a boundary so that those agents only go around or fly around inside the boundary that I have set, which in this case, this sphere, which might be a bit small in this case, but let's see. Okay, so to do that, I'm going to update this balance point wrangle that I created. But before doing that, since there are several parameters that I have set, like these and this one, I'm going to promote this to a controller. So open up the editor parameter interface and check for bit linking parameter, and I'm going to create the separator and set some let's set the label basic flocking, or just say flocking. Okay, right, now's the time to go back to the solver and drag and drop these values. So aligning radius, separation radius, cohesion radius, alignment scale, separation scale, cohesion scale, max points. I am not sure if I want this. Well, maybe let's set it to a global parameter, since maybe I can reuse this value. Okay, and also a speed. This speed is for those alignment, separation, and cohesion scale, so let's set it to here. Okay, and since this is a bit ambiguous what these are, so maybe I can rename this. For the point update point position, there's maximum speed. Maybe I can set it as a global variable right here. Okay, now it's time to rename. So max PTS, let's say max search point number, max search point number. 0 to 10 is fine. Maximum speed, so max speed. Okay, alrighty. Now for the alignment radius, I'll say ally. Just gonna give a space in between. Ally radius separation radius, cohesion radius, cohesion radius, alignment scale, separation scale. This is cohesion scale, and speed, flocking speed. Right, and for the speed, let's say the maximum is 0.1. And for the scale, the maximum is 1 is fine. The cohesion, the radius 1 may be fine. For maximum, maybe not. Maybe let's set it to 5 for the maximum for the radius, searching radius. Yeah. Right, now let's apply. Okay, so let's update those boundary function. So what I want to do is to update the bounds, those vectors or agents to inward whenever it tries to go out the boundary. So to do just this one, and what I could do is to retrieve the normal direction of this primitive and use that as information which way should should those vector go once it's been bounced, once it's been going outside of the sphere. To do that, I need to know whether the point has been going outside of the geometry or not. So that's the first thing I need to do, to check if the point is inside or outside this geometry, the bounding geometry. To do that, I guess there's a lot of ways you could do that. One thing I could do is to calculate the dot product between the velocity, or maybe no, not the velocity, the the projected point position. First create the vector between the current point and the projected point position on a surface. So meaning we have the surface as a boundary, and let's say this is the point and this is the point that we want to check. First thing we want to do is to project the points on a surface, and as a result you'll be able to get this vector, right? And at the projected point you also want to retrieve the normal direction for the surface, and the normal direction is always facing outward in this case. So using those information, we can calculate the dot product between those two vectors, v1 and n1, or v2 and n2. So in this case, v1 and n1 dot product gives you, since this is facing to the same direction, it always gives you a positive value. But if it's facing the negative value for like things like v2 and n2, then the dot product result will give you a negative value. So this is a kind of a condition you can use to check whether the point is inside the sphere or not, or inside the geometry or not. So let's try to do that. Let's try to write that code. First of all, I need to project the point. I need to project those points into the surface. So first of all, I'm going to filter this to only work on the agent group. Then there are probably many ways you can do to project the points to a surface. What I could do, there's something like minpos or xyz dist. Now I would prefer this xyz dist because it can provide additional informations like the point information where it has been projected on primitive, like the primitive number of primitive and the UV, in order to specify in which point it has been projected on the surface. So having those values, I'd be able to retrieve the normal attribute of the primitive at this specific point position. So let's use this one, xyz distance, instead of using mim pos, right? I don't really need a distance, but what I just need is those primitive and UV actually, and projected point position. Well, this one doesn't give a projected point position, but actually I can retrieve that by using these value. Okay, so let's do that. Let's say, so in order to use that, I need to have an empty variable for a primitive number, and also the UV, and I'm going to call xyz dist. And the surface that I want to check is on the second input, using at p as the current point position. I want to have the primitive and UV. Okay, and as a result, I'll be able to get this primitive value and the UV value. Right. Now, next thing I would like to do is to retrieve the projected point position out of this primitive value and the UV value. So I could get that by, let's name this projected point position using prim UV, second input p prim UV, and I would like to get the normal direction as well. So projected normal value, which I can use the same prim UV functions access into a normal direction at prim UV. Okay. Now it's time to next thing I would like to do is to create a vector from the current point to the projected point. So let's create that by, let's just name this here, and that is p projected point position minus current point position. Let's normalize this. Okay. What else? And now that I have got the direction value and as well as the normal value of the surface, I could calculate the dot product between those two values. So first let's calculate the dot product by using dot function between this direction and p norm, the surface normal value. Okay, and here comes the condition: if the dot val is positive, or else. Okay, if the dot product is positive, it's facing the same direction, meaning the point is inside the sphere, right? So that's in that case you don't need to do anything, I think. But if the dot product result is negative, then point is outside a surface, so that's where you need to change the direction. So I don't think I need this condition right here. I'm going to flip this to, if the dot product is negative, then I want to control the current point position. Okay, so to do that, let's think what kind of bouncing I could think of. So let's say the point is outside the surface, right? And what I have as an information is the projected point position and also a surface normal direction. Okay. Now what I could do, first of all, I could move this point to the projected point first and maybe offset a little bit inside just in case, right? So the initial position will be somewhere right here, but I also need to update the velocity for this point as well, since the point might have been moving to to this direction using velocity. But if I have the same velocity kept even after I have moved the point inside, then in the next frame the point will just go outside again. So to avoid that, I want to reflect or mirror this velocity to the other direction, and this mirroring could be happen based on this n as an axis. So meaning I want to use this n to use this as an axis to rotate this velocity, which is going this way. And first thing I could do is to multiply. It's a bit hard to see here. Okay, let me just delete this and redraw. Okay, Okay, so let's say that this point, which is outside the surface, is going this way as velocity, and the normal direction for the surface is this axis. Okay, and when the point is going outside, first thing I would like to do is to move the point just a little bit offsetted inside the surface. Now the velocity is still at the same direction, so the first thing I would like to do is to multiply this velocity by -1. So in this case, it will create a velocity like this one. Now this is a bit unnatural in terms of bouncing, because having this velocity means that the point has come from this direction to here. So bouncing to the same direction, to the opposite direction, is a bit weird. So to avoid that, what I want to have is this kind of a reflection. Right. So to have that, what I could do is to rotate this angle, multiply by v multiplied by 1, multiply by -1 by 180 degrees, using this n as an axis. And as a result, you will be able to have a vector going this way, which is a proper reflected direction. Makes sense, hopefully. So that's what I want to do here. Alright, so let's do that. So if the dot product is negative, then first thing first, let's create a rotational matrix so that in order to use it for the rotating the vectors. So starting from ident, and rotate this matrix by 180 degrees, which is equivalent to pi, using the normal direction, in this case a p norm, as an axis. Okay, so I'm ready to use this rotational matrix. Next thing I like to have is the vector that I want to rotate, and that vector is, let's name this vel, and that is the current velocity multiplied by -1 and rotated by the rotational matrix. Okay, now I can update the current velocity with this velocity, this newly created velocity. Now I also need to update the point position. First of all, I want to project this point to this projected point position on the surface, and also give a little bit of offset inside the surface by adding a little bit of normal directional value. So I can use this one. So p with the negative value. So p norm multiply by some value. What kind of value should I use? Well, in this case, maybe I could use the maximum speed that I have set for somewhere around here. Or maybe, yeah, somewhere around here, update pause. Okay, so I'm going to create a parameter, max speed. And I'm going to multiply this max speed. Okay. Now, let's see if it works, if it's working. Now I have to promote this parameter max speed, and let's copy the max speed value right here to this one. Right. Okay, and let's see if the bouncing is working with this geometry, bounding geometry. And yeah, it seems like the bouncing is working. Now things seems a bit too fast. Let me turn on this real-time toggle, as well as controlling some of the parameters. Like, let me set the maximum speed a bit slower, so 0.05. Okay, now maybe there are a bit of too high cohesion power, so let's try to scale this 0.5 for the cohesion, and let's see what happens. Now you see that the separation distance between those two neighbors become a bit wider. Okay. Now let's also set the separation scale to 0.7, maybe a little bit smaller than the alignment. And for the alignment radius, I'm going to set it as 1. For the separation radius, 0.5. Cohesion radius, 0.5. Okay, that might be too small. Might make it 1. Okay, starting to create some kind of crowd here. Now if I increase the number of points, like 1000, it's a bit weird that seems like the point is moving on this direction, this single direction, either positive or negative. It's a bit weird, isn't it? Maybe I'm missing something here. Let me check. Okay, so to check that, I could check the velocity value right here. Okay. Well, it doesn't look that weird, is it? Also, let me check if the initial attribute velocity value is or if really randomized or not. Seems okay. So maybe the parameters that I have set is not good enough. Let me check again. Okay, so let's say the alignment radius is 0.5. And 0.5 and all those to 0.5, and also the cohesion scale to 0.3 and separation scale to 0.5 or something, and set the alignment scale to 1. Keep it 1. And maybe the flocking speed might be too fast. Let's set it to 0.01, and the maximum speed keeps it as 0.05, and let's see how it goes. Okay, I think I'm still seeing some direction which doesn't really seems like a random direction. All right, let's debug this. I think something is wrong here. Okay, now What if I don't have this bouncing? Now it goes to right hand side and left hand side with a lot of crowds. Might be weird, and I can see that these points are going to the positive direction, is going to the negative for x, y, and z coordinate. So I guess something must be wrong. That's just my guess, but I think there is something wrong here. Okay, so let's go back to the forces and see where I could fix. Now the first thing I could do is to disable those separation values to see if some of the forces are working correctly or not. So currently I only have alignment. Now at this point I do seem to have some problem here. Now what if I don't have this alignment as well without having these? Only the current velocity, and now I can see that it's separating randomly, so the initial velocity looks fine. So I guess this alignment, the first alignment, might not be correct. Okay, let's check that. Alright, so I have this new points type is equal to the current type. Let me check the number of founded point number. So I think okay, well at least there's 1 to several numbers, so I think that's fine. And I am making sure that I'm ignoring the current point number. Okay, and I'm calculating the distance, and I'm accessing to the velocity. Now is that correct? Is that correct? Maybe the alignment force was a bit too big compared to the other forces. What if I don't have this alignment and have both cohesion and separations? Then what would happen? Okay, now is it working? So I do have separation and cohesion. Okay, right after this one, do I have any updated swarm acceleration value? Nope. Okay, there is a problem here. I seem to have only an alignment forces. And why is that? I do have scale. Okay, and I do have separation. Now I guess those functions not really working as I intended to do. Let's check length and PTS. Okay, well at least there's one means it's finding itself, so it doesn't really mean anything, but there's at least 4, so should be okay with the numbers. Now okay, PT num Colrad is coming from here. Distance between the end pass normalized. And let's have this apply to cohesion and see if there's any forces being created. Okay, well, actually there is. So I guess that's fine for the cohesion. Let's check the separation. Separation is also fine. No, but what is this one? Okay, ACC. Well, I do have ACC value here. So I guess the calculation is working, even though I don't have any alignment. So, what seems to be the problem? Not sure. Let me scale this ally scale down to like 0.3 and see what would happen together with the bounds. No, maybe without the bounds. Okay, gonna go outside. I think I need to reset this. I'm not really sure if this is the correct behavior that I'm getting. If anybody watching this and if anybody have any comment where it seems to be wrong, that will be appreciated. Well, I have time to just test it out, but if you get bored you can leave at any point. Alright, so let's see. Line scale. If I set this to 0, all these goes to the... If I set the separation and cohesion radius to 1, okay, and what if I set it like radius to 1 as well? Forgot to make this some value here. Now this is obviously something seems wrong. Maybe the number of searching point. If I increase this to 50, might be better. No, not really. Not really. I set it to 0.5, 0.5, 0.5. Okay, now I am stuck. Okay, let me check the code that I have written previously and see what seems to be wrong here. Right. Going into the update position. Okay. What if I don't have this function? Swarm ACC. Well, obviously something must be wrong here, right? Do I have correct calculations? Alignment plus cohesion plus separation. Okay, separation, normalized separation, cohesion. Maybe I'm having some duplicated forces somewhere. Could be. Let me search. Let me search for alignment if I have any something. That's correct. For the cohesion. Looks correct. What? Any comments? I'm not really sure if anybody was watching this. If not, I'm just going to finish this at this point, since I don't know how I can fix this at this point. Right. I think this is correct. This one is also correct, I hope. Normalizing the current velocity, and I'm updating the current velocity with the swarm ACC, and I do have the swarm ACC right here. Yeah. Okay. Seems like some of the forces not being updated, but I guess that's fine. Max speed 0.05. It's fine, I think. Okay. Where is wrong? Where is that? So I have those alignment, radius, and scales, max points, speed. All these numbers being properly used. And based on the agents, new points, I'm really guessing this alignment is something wrong. Doesn't it? Seems a bit weird, isn't it? But if I increase the radius of the alignment, it should go to the same direction for all these points, but not exactly. If I set it to 10, I think it should go to the same direction. Let's raise up the number of the yeah, I did now, but what if I set it to 4,000? It doesn't seem like it's searching for the closest. Well, it's been split it into half. Yeah, something must be wrong. Okay. I have to check back the new points parameter. Maybe I'm missing some of the parameters orders here. Okay, so geometry, PD group, which in this case type equal to ith I type should be fine, and current point position, maximum distance for the alignment. Yeah. And and maximum point number. Right. Not really sure why. What if I don't multiply it by this f? Would it change? Now it seems to give some interesting value. I think this is the one that I am looking for. So this fit function doesn't seem to do what I'm hoping for. Okay, that is because maybe after I have retrieved the velocity, I might need it to multiply after I have retrieved velocity. Let's see. Now that it does seem to work. Wow, that's pretty weird. Now I couldn't just multiply this by f. In this case, this gives me some weird result. Oh shoot. I see. So somehow by multiplying this point with f, I think it provided a single float value. This value became float value, and as a result, both x, y, and z had the same values for velocity. So in order to prevent that, I needed to separate, first accessing the velocity, then multiply that with the value that I want. So I guess I need to do the same things for other cohesion and separation. Okay, I think I learned something here. A bit weird behavior of x. Okay, now this should do the job to create a bit more wanted result. Okay. Yep, I think it did. Now, obviously the searching radius or the power is a bit too high for everything. So let's set the alignment scale to 1 and the separation scale to 0.5. Let's also set the number of points to 1000. And the search radius for the radius, the alignment to be 0.5. Okay, finally I had something that looks like a flocking system. Right. Right, so now it's just a point, so maybe I might be interesting to create some trail. Now I could do like trail node, but the problem with that is it only works on every point included in that one node. Cannot be used with the filters like groups, so instead of using it, I'm just gonna create the trail with a wrangle, right? Okay, so point wrangle. Going to name this gen trail, and I'm going to look for the agent particle, agent points, and at the point at each frame, let's also set the color for the trail, set the yellow. And so I'm going to set point attribute ct pt with ct, and also I'm going to set the group, set point group 0 trail pt to 1, and at some point I want to delete the trail, so I'm going to give a life attribute as well, starting from 0 and iteratively counting up by 1, and set point attriv 0 id pt I at id. I'm just going to copy the ID value, and I'm also going to copy the name value as well. And what else? I might want to set the type of the trail, since if I want to create another type of agent, then I want to change the type as well. So I'm going to derive it from the current type of the agent. I guess that's enough for now. And I want to reduce the number of trails. I need to delete it at some point. So I'm going to create another point wrangle. This time del trail, and I'm going to look for the trail node, a trail points group, and then set some conditions when to delete that. So first of all, I'm going to iteratively add the life value by 1, and if the current life is more than some maximum trail life, then remove that point. Okay, so it could be like 100, 200, maybe 100 or 50. Okay, should that be enough for now, I think. And let's see, play it. The tray has been created for each agent and creating this kind of trail. Now I can create a add node to create a polyline for this trail. Let's say polygon by group by attribute, and I'm also going to look for the trail node, trail group, and the attribute name is that I want to use is name. Didn't work. Did it work? Yeah, it did work. Okay, and let me reopen this file and check this by playing it. Okay, now it seems to work. Trace seems to work. Now I might want to color this trail based on the life values, so let's give a color node. Life based on the life, and in order to use this, I think I need a maximum life attribute, so parameters. So let's have that as a global parameter here. So going back to the SOP solver, there is it's a max trail life here, so separator label, let's name this trail, and okay, I think I can just drag and drop. Okay, drag and drop this max trail life here. Let's give a space. Okay, and let's set it to 100 as maximum value. Right, what else? Gen trail. For this one, I don't have any parameters, so I guess that's it. Now, going back, I'm going to copy this one and then place it as a maximum value for the life here for the color ramp. Then bring these to the left, the white to the left and black to the right, so that the newest trail point has a brighter color. The older trail color will be used as black. Okay. Alright, looks good. Looks good. And let's set the group for the color to trail. Okay. Now I have just created one single agent type. What I want to do now is to create another type and use the current agent as a prey, and I want to create another type as a predator and create some interaction between those two agents, like follow and fleeing and following. So to create another agent, another type of the agent, what I could do is to go back to the initial attributes here. Currently I'm setting all those points as a type 1, but I could have some random values with the threshold to pick one of the points, several points, to make it as a predator. So if rand at p plus some constant value is less than some predator ratio, then I could set the type to other type to determine that it is a predator. Let's say it's type 2, and for the type 1 it's prey. So prey and predator. Right. So I have type 1 and type 2. So for this ratio, I can control it maybe with the global parameter, or maybe I could make another sections here controlling the values for the prey and predator. So prey, predator. Okay, and the first value that I want to have is this ratio. So let's uncheck this link, drag and drop, and predator ratio. And let's set it from 0 to 1. If it's 1, 100% of the points will become predator. If it's 0.1, 10% will become predator. Now let's also change the color for this one as well by using this color node. So copy this one, and if the type is equal to 2, let's set it to red as a dangerous color. Alright. So I can see that I can control the number of points here. Let's set it to 5%. Okay. Now let's try to run this to see what happens here. Now every agent, including the prey and predator, will just create the particle, the trail, and those prey and predator doesn't interact to each other currently because I didn't set anything, and only the same type, only the one that having the same type is interact together. But currently there are a small number of predators, so doesn't really do much. And I don't think I would want those predators to act like a crowd. I want to make those predators walk as an individual. by not interacting with other same type other predators. So meaning that I want to avoid using this flocking forces for those predators. So to do that, I could make a filter, maybe inside the code or using the group. Maybe I can use the group. So I can say if the type is equal to 1, then run the code. Meaning if the type is equal to prey, then just use this flocking. Otherwise, don't update the flocking forces. So in this case, only the prey agents will going to be used using the flocking. Let's see the result. Let's look at the red points. Where is that? It's just moving straight and just bouncing with a boundary. That's because there's no additional forces applied to it. So it's just randomly going straight using initial direction. And the reason why I'm seeing this yellow points is I think it's the cache problem with Houdini. Okay, now it's gone. Now what I want to make for this predator is to create an interaction with these prey. So I want those predators to follow the nearby preys, right? That's pretty simple to think. Now currently the trail seems a bit too long, so I'm gonna reduce the size so that I can see a bit better. Now I also might want to color this trail for the red one, the predator, so that I can see it clearly which one is the predator. So to change the color, I can go back here. Now this is using just the trail group, but I didn't set any type for the yeah, actually I did. So I guess I can use this trail type to make the different color for each trails. So for the trail type to equal to 1, I can use white. For the trail type equal to 2, I can use red. Like this. Okay, now it's a bit more clear. Getting a bit more interesting. Now, obviously there's no interaction between those two agents, so that's what I want to do next. Let's go back to the solver and where can I do that? Well, to create a additional force, I guess you need to do it right before this updating positions, because in this updating position it's using all those forces to update the position. So the place where I want to create the force is somewhere around here, before the flocking or after the flocking. Well, let's create after the flocking. So point wrangle again, and for this one I want to create a fleeing forces for the predator, for the preys, and following forces for predator. So works for, you need both agent to be looked at. Okay, and I also need to check, I need to create a condition whether the type is 1, meaning if it's prey, or if the type is predator, which is equal to 2. And I am going to start by creating a acceleration value set as 0, and I'm going to update this as a final acceleration value for either predator or prey. Let's name this prey predator force. Okay. Okay. Now let's write some code here. It's pretty similar to what I did for the alignment or cohesion for separations. Let me see what I could do. Now for the prey and predator, now let's say this is the prey and this is the predator. Now simply what you need to do is to create a vector for predators going looking for the preys, and for preys going to going far away from those predators. So it's pretty similar to the cohesion and separation functions that we created for flocking system. It's just the only difference is that the target that we are looking at is different. So this point, this prey is only looking for those predator types for the search within the search radius. And for the prey and predator forces, this point is going to ignore those same type, but only look for those predator type. Same for this predator. This predator only looks for those prey type to follow in order to create a forces. So think like that. It's pretty similar to what we have done in alignment, separation, and cohesion here. So what I could do, I could probably copy one of the code like cohesion and use it as a template. Okay, so going back to the prey and predator, let's open up the code and let's copy this one and paste this one and paste it right here as well. Okay, and for this one is predator force. This is for prey force. Okay, and I do need a search distance, search radius for both prey and predator, so let's set that. So for the prey search, I'm gonna name it prey rad. For the predator, rad. And I don't actually need a scale because I don't need to calculate the relation because there's no like multiple forces here. There's only one type of force for each prey and predator. But I do need a speed value for fleeing and following. So prey speed and pred speed. Okay. Oops. Well, I think I need to rename some of the code because I'm reusing those same names. First of all, for NPTS, I have to declare it as a variable, as an array. And for this one, I want to replace this with prey, and I want to replace this with prey rad. And this is where it should be different. What I want to do here is to search for the predator for preys. So I'm going to say I'm only looking at the type equal to 2, which is equal to predator. Okay, other than that, it should be the same until here. I think I need to replace this with prey rad. And okay, so let's think about if this is the correct direction. So for the prey, I want to go away from the predator, and this is the predator's position and pause, and this is the prey's positions. So this vector is trying to go from the current point to a predator, so that's not a good. What I want to do is to subtract current point position with the predator's putting position so that I could create a fleeing vector value. Then multiply by f and update the prey. Okay, and finally I am normalizing the prey with binomial. Wait, I did have this commented out, meaning I might have to go back here. I think I forgot to uncomment. Oops. This one. Alright. So last time I only had alignment values. Well, didn't realize that. Okay. Now for the prey and predator, so that's I think this is good for the prey. I think I can then multiply this by a prey speed. Yeah. Yeah, and update the acceleration with the prey. Yeah, I think so. And for this one, for the predator, I'm looking at the type equal to 1. Type equal to 1 means looking for the preys and using pred rad. What else? This one as well. Pred rad. And this one is correct because this is equal to cohesion trying to follow the preys. So that's good. Now I need to change this one to pred. Okay, this one as well to pred. Then going outside of the loop and update the pred with the normalized predator vector. And then multiply it by a speed, pred speed, then update the acceleration with this predator vector. Okay, 11. Okay, I'm missing the comma again. 11. Still have some errors here. Where is it? Type 2 prey max PT. Okay, I think I don't have this max PTS, so int max PTS. Right, now let's accept. Enable this one. Now let me just disable this frame predator force for now because I was commenting out this cohesion and separation, so I want to see what's the difference by enabling it. Well, seems pretty similar, but it does joining, and I can see that by changing some cohesion related values here. So let's say cohesion scale is equal to 1. Well, should make a really packed cluster. Yeah, it does. So I think it's working. Good. Good, good. Going back. Right. Looks good. Now maybe I want to have a bit more spaces between. Okay, now let's try out the prey and predator with a small number of points, 100. Okay, so enabling this. Now what I need to do next is that I do have acceleration being created, but I didn't store it in any attributes. I do to do that. So I'm going to create a value like PPACC, like prey predator accelerations with the acceleration that I've created. Then use that inside update position together with this one. So what I should do is to add up the additional accelerations, in this case PPACC, right? And that's it. that's probably it that I need to do. Now I didn't promote any parameters for this one, which is for the radius and the speed. So let's set that as well. Let's set the prey radius to 1, predator radius to 1, play speed to point like 0, 1, and predator speed 0.02, so that the predator is 2 times faster than prey. And then maximum points, maybe I can just use the same point number which I've used somewhere for the, I think I did have this one, right? Let's also set it to 10. And let's copy this channel for the prey and predator. For those 4 parameters, I can promote this into a controller again. So let's open up and go back to the subsolver. Alright, and check for bit linking. Now, prey rad, predator rad, prey speed, and predator speed. Okay, let's rename this. So prey rad, this one predator radius, and this one is a prey speed, predator speed. Okay, now let's set the speed maximum to 0.1. Prey rad, let's set the maximum to 5. Okay, let's now see the changes if those forces are being used. So let's check the position of those red points. I'm going to make those point size a bit bigger. Okay, and let's play it. And well, is it changing? It's not really. I can't really see if these points are being updated. It seems like the red one is still going forward, just straight forward. So let's see. First thing I would like to check is if PPACC is being updated for some of the value and is not. Maybe the search radius is a bit too small based on those distances. So to try out, I'm going to increase the search radius to something like 3 for both. Now it still doesn't seem to change its direction, so let's check again. And but there is some forces right here being produced, so I guess the acceleration itself has been created for prey and predator. Yeah. Let me just check. Right. Okay, I think that's fine. Now I'm not sure if it's being used here. Well, I am accessing to this PPACC right here, and well, now I'm losing. Okay, I think I have made some mistakes. Okay, name convention typos with the name of the attribute PPACC. Okay, that should be the problem. All right, let's see. Now the red one start to move its direction, and as you can see, the blue one, which is being fleeing from the red one is moving like zigzag. And I think this code is working properly as I expected. Okay, let's increase the number of points to see the result again. Going back, make it 1,000 points. And you start to see those red one walking like a dog, shepherd dog, those blue one like a sheep. So there's a relationship between those two types of agents. One is following, one is fleeing. Okay, yeah, this seems to work. Now, next thing I'd like to do is that this seems pretty enough, but the final step that I want to do is to create a fireworks when the predator reaches to a specific distance to a prey. So let's say when the predator touches, I want to create some effect to show that the predator has catched a prey. And for that effect, I'm going to create some fireworks effect, which in reality I don't know what that means, but just for fun. Okay, so let's do that, and that's going to be the final things that I'm going to do here. Right, let's go back to the solver, and let's think about the conditions here, right? It is still based on the distance, so it's pretty similar to what we have done here. But in this case, I do not need to create another force, but I need to create another geometry or like effect with the conditions, right? Based on two different agents. So to do that, I'm going to do it right after the bounce, somewhere right after the bounce. Okay. So let's do this somewhere around here after the bounce, just right after the bounce, using point wrangle again. Let's name this gen fireworks. Okay, and let's think about what kind of information that I need to use in order to create the fireworks. Now obviously I need to check the distance between two prey and predators, and I could either walk on the prey. I mean I could filter this point based on the predator or based on the preys, right? And I could do either way, but I guess it could I'm not sure which one is better. What I want to do is that after the predator catches the prey, I want to like reset the position of the preys to make it look like it's being eaten up and being generated at some other positions. So to do that kind of simulations, it might be better to create a code based on the preys, but I could do the same things based on the predator, so it doesn't really matter which one I should choose. Well, since there is a less number of predator in the space, let's choose predator as a base to make it effective, right, for calculations. So group type equal to 2, right? And first thing I'd like to do is to check for the new point for type other type, which means type equal to 1 with the current point position with some specific search radius. I mean, in this case, a touch radius, I guess. So it has to be really small enough to determine that it's being touched, right? Oops, I guess I'm missing some more parameters. What that is? in this case I don't want to use near points, but I just want to get a single point, so a near point is fine. And for the touch radius, let's say 0.2 for now. Okay, now let's see what I can do. First of all, I need to check if I have found out any point or not. If so, the point should be positive. What's this? Okay, and if it's positive, then I could consider that those two different types of agents being touched. So in that case, I want to create a bunch of particles and that point positions to be a base of fireworks, to spread it out all over the direction, right? And I could determine the number of particles here. Maybe I can parameterize this pnum. It's set to 50 for now. Okay, and going to create 50 number of points using for loop. And create a new point at where the predator touches the prey. So maybe I could use the position of the prey itself, so vector, I can retrieve the point position of the prey by saying npos is equal to point p at npt, right? Now I can create a bunch of points at that point positions. The next thing I would like to do is to create a random directional vector, which I can do that by creating a random function plus some constant value subtracted by 0.5 for x, y, and z, which I did it for initializing as well. Okay, and I could normalize this to make all the direction lengths of 1. Okay, now next thing I could do is to set up some information or attributes to this point that I have created to determine that this is the point for the fireworks. So, and I want this fireworks particles to move as well based on some frames. So meaning when the predator and prey and predator touches, then I want to create the fireworks particles splitting all over the praise, but using some kind of gravity to have this kind of flows like a real fireworks. So to do that, first I need a directional vector going to the random direction. Then at each frame I can add this gravity accelerations really small value to this velocity to give this kind of curved direction. And at some point I want to delete this fireworks with some life value. So that's the things that I'm going to do here. Now first thing first, set point group. I'm going to set the group called fireworks to this point that I've just created, and I am also going to set the life here, set point attriv starting from 0. And since I would like to also create some lines connections between the trail of the fireworks, I'm going to use that. I'm going to create the name name attribute derived from a current ID, but this ID, having just this ID from a predator ID is not enough because I'm creating 50 new points here, so I have to create every 50 points unique in terms of name. So I'm going to create another string coming from this I value, which is from the loop. Okay, I think that should be enough, hopefully. Right, now what else? After I have created the point, maybe I can color this fireworks point to yellow. Okay. Okay, I was missing a parenthesis. Okay, what else? Yeah, I also need to set the initial velocity for the fireworks for each of the points, which I've created right here. So let's do that by set point attriv 0. Let's say vel et set 0 rand vec. I'm using the same velocity attribute which is using for the agent, but in the update position it's only looking at the agent, so this velocity is not going to be, the fireworks velocity is not going to be updated right here. But let me see if I can do that. I mean, I could still use the same update position node to update the fireworks position, I guess, but I do need to make some conditions here, and I do have other kind of forces, so let's just make another point wrangle to just update the fireworks, which will be easier to see. Okay, now that I have created the single points at the same position, starting position of the fireworks, next thing I could do is to move the point, the prey point, to somewhere else to make it look like it's been eaten up. Okay, so maybe I could also delete it and recreate it, but to do that I need to recreate all those necessary attributes as well, so I just don't want to do that right now, so let's just move it to make it look like it's been deleted. Okay, and I want those points to be created somewhere in the space inside a sphere. So what's the best way to do that? In using coding, well, just creating a random points inside the box, the bounding box, is easy enough, since you can just do the get bounding box size and say get the minimum maximum, and then you'll be able to get the random position inside a box. But in this kind of geometry, which you want to change it for other kind of geometry, like could be more irregular shape, then that kind of operation would not work. But maybe I can just use a minimum position if it's outside the geometry, if it's outside the surface. So I could still use, I guess I could still use the bounding surface, and if the point is not inside the surface, then I could just project it to the surface. Maybe that's the way to do it. Okay, so I'm going to connect this boundary box, bounding surface, to the second input for the generation fireworks. Then first thing I like to do is to create a random point inside the bounding box. So first of all, I'm going to create the empty minimum and maximum vector, then use the get bbox function for the second input. Then you'll be able to get the minimum value, minimum point position for the bounding box and maximum point position of the bounding box. Now you want to retrieve the random position inside a box using rand at p multiplied by or plus some constant value. And the value you get from this random value is in between 0 to 1. So what you want to do is to refit it so that the range will become in between minimum to maximum. So fit rand pos, which is in between 0, 0, 0 to 1, 1, 1 to minimum maximum. Yeah, should work. Now now that I have the random positions, it's time to check if this position is inside the sphere or not. And I could do the same things that I did inside this bounce. So maybe I could just copy some of the code here. Or somewhere around here, right? So somewhere around here. Maybe I should make it as a global function, but I'm just going to skip that. Right. And go back to the general fireworks, paste it. Okay, so let's check what I need to change. First of all, this one should be replaced with the random position. And the primitive, what is primitive? I need to create empty primitive values, int prim, and also empty uv. And now that I get the projected point positions, and also normalized a normal direction, and now I calculated the direction between the projected point position with the random point positions, and then calculating the dot product. And for this one, this is the place that I could change. So if it's negative, which means it's outside the surface, so what I could do is to just update the point positions. In this case, a random point position. Okay. And finally, I think I also need this parameter. So let's have that max speed. And finally, I could use this random pos to update the prey point position, which is at npt right here. So set point attriv 0p npt with random pos. Okay, that's a lot of coding. And I need to promote this attribute or parameter that I have created, max speed, which I can copy it from somewhere from here. Okay, now let's see. Okay, now it should create a bunch of fireworks points when the predator and prey touches. Now currently the fireworks point doesn't really move, so you cannot really see what happens after it touches, but let's see. Okay, I'm seeing some okay, so you see that at some point those yellow points being generated, and I think there are 50 points being generated at the same positions, so that's good. Now next thing I would like to do is to animate those points, fireworks points looking like fireworks. Okay, so to do that I'm going to create another point wrangle. Oh, it's a lot of wrangles here. Okay, so how should I name it? well, I could say firework. Like, first of all, I need to have a point wrangle again, and let's have it just after the generation fireworks and say fireworks update. Okay, and I am only looking at the fireworks groups, which I have created right here. This one. And for each of the fireworks points, I'm going to update the life so that at some point I want to delete the points. Max fireworks life. Remove point. Okay, but that's not it. That's not over yet. We need to create the acceleration value to create the forces for each point to move the point, right? And we already set the velocity value, so what I want to do is to update that velocity value with the acceleration, in this case the gravity falling down. Okay, so let's create that. Let's call this gravity equal to set. I can just say 0 0 and CHF gravity value. So I'm going to create a negative y value here. For the y value, let's say 0.01 or something, maybe a bit more smaller, 0.001. And for the max fireworks life, let's set it to 20. Okay, and what I need to do is to update this velocity with this gravity, and I also need to set the maximum speed for this velocity. So what I could use is the same value that I have here. I could share this parameter for this one as well. So let's bring up this max speed. Paste it right here. Okay, I think I pasted something different. Okay, copy this one. Paste it right here. Now, let's check if well, I can just copy and paste where I'm restricting the velocity value somewhere around here. Okay, I can just copy this and go back to the fireworks updates and paste it right here. This should just do the job. Alright, now within the same node I can update the point position with the velocity value. Okay, now let's see what would happen here. Play. Oops. What is this yellow stuff? Okay. I do see something here. If I play it. Okay, I do see a little bit of a problem with this connection of the trail. That is because right after the prey has been eaten up by the predator or touches the predator, then I'm moving the prey's position, so that's causing this kind of disconnected lines. So to prevent that, I need to update the attributes where I'm using it for connecting the lines. And I can do that by going into the fireworks update. Or maybe not. Maybe do the fireworks fireworks. And this is the place where it's changing the position. So right after I have changed the position of this prey, I could also update the name attribute with by how do I do that? Maybe I can retrieve the current current ID of this NPT by saying int NID is equal to 0.0 ID at NPT, and then update the name with the new this I2A NID plus and I2A plus, wait, maybe I2A ID NID plus endpoints, or I guess I need to use the number of agents, but I cannot use the endpoints because that includes the number of fireworks as well. So in order to retrieve the number of initial agent numbers, I can connect this one to the third input and say endpoints to, right. Now this should do the job. Now I might also need to update the ID as well, so attriv 0 ID pt NID plus endpoints 2. Okay, let's see. Now there is no more disconnections, and I do see yellow points being created and spreading, but I cannot really see if this is creating a effect like a fireworks or not, because it's just a point. So let's also create the trail for each of the yellow points to see if I'm really getting the result that I'm want for all those 50 points at each of the position. Okay, so to do that, first of all, let me check if the velocity has been properly updated to each of the point. Now this should be it. This should be okay. Well, I might be missing some of the seed here, because by just using the point, I'm having the same random values for all those 50 numbers of points. So I think I need to use I for some additional seed value. Maybe add one more values like this one. Okay, let's see. Now it looks more like a fireworks. All right. Now let's also create a trail for those fireworks, shall we? Okay, so let's see where I can do that. I wonder if I can use this same genTrail function or genTrail point wrangle to create for the fireworks as well. Let's see. So what it's doing here is to create those points, set the color, trail, group, life, ID, name, type. Okay, well, I think I can do that. I think I can use this one to create the trail as well. But maybe might be better to make it separate so that it's easier to see. So I'm going to copy this once, and for this one I'm going to say fireworks trail. Maybe somewhere here. And for this one I'm going to look for the fireworks, and then set the color to yellow. That's fine. And for those, the normal one, I'm going to set the color to white. Okay, and for the fireworks, so let's see. First of all, I'm going to change the name of the trail group to Fireworks Trail. Okay. And I don't need a trail type for this one. Okay. And what else? That's it, I guess. So I do have a life, name, ID. Okay, so I do need to have a function to delete this fireworks trail with using this life value, just like I did for this delete trail. Okay, so let's copy this one as well. Name this del fireworks del trail. For this one, I'm going to look for the fireworks trail, and if the max trail life, currently it's set as 10. Now I might want to change it to different channels here. So let's delete the channel. Let's say 10 for this one. Okay, now I think all these stuffs are ready to go here. There are several channels, several parameters that I haven't promoted yet. But let's first see if it's going to work or not. Now in order to create the trail, I'm going to add another add node with a polygons by group, fireworks trail, and by attribute name. Okay, and what else? And maybe I also want to set the color for this trail as well, which could be similar to what I did here. So copy this one. This one I can set the type fireworks trail, and then currently I don't have any channels, so let's delete this and set it to 10 and set it to yellow. Okay, let's see how it goes. I'm seeing the points. Let's reopen this. Okay, now I am still seeing the points. Okay, but oops. Okay, I do seem to have some problem here. At some point I do see a bit of unwanted connections to this fireworks trail. Some points work, some points not. Now let's see. I guess it's based on this name attributes right here. So that should be the problem. That should be the cause of the problem. Okay, so let's see what I could do with it. Getting tired. Alright, so let's go back and look at the delete firework trail, or this one, gen trail, or gen for this one. So I am promoting the exact string name here. So initially it has been created right here on the gen fireworks, this one, right? And for okay, I guess I needed to avoid using I at ID, but I guess I needed to use the prey ID instead of the predator ID. I'm not sure if that's true. Not sure. Maybe not. Well, but I am missing the ID being provided to this one, so let's try to add that. Set point attriv 0 ID pti at ID. Okay. Now yeah, I guess there is a chance that some of the points is sharing the same name. So to prevent that, at each frame the same predator is looking at a single point, so I can add another name like based on the frame. In that case, all these points name will be unique. Promise to be unique. Yeah. Finger crossed, and let's see what happens. Alright, looks good. Now it's a lot of fireworks here. That is because the speed of the predator is really high, so there's a lot of chance that predator catches the prey. So if I reduce the speed of this predator like to the 0.15, then I think there will be less fireworks being happening. Well, looks same. If I reduce to 1, still a lot of... Is this working? Not sure. Let me make it really slow. The predator to be really slow. Okay, it's a bit weird, isn't it? I'm not sure if this thing is working. I gotta check it. Going back to the prey and predator. So there is a pred speed and predator prey speed. And is it actually used? I guess so. Yeah, I guess so. Yeah, it is being used. Oh no. Oh yeah. Yeah, it did. It did. Seems like maybe I can increase the radius for the prey. Like currently it's 3, and let's set the predator radius to 1. Let's see what happens. Problem seems to here is that what if I set it to 0 for the predator? Now, I guess it's correct because the predator is just going to the straight direction when it's set to 0, so that's fine. But the prey speed, the prey is not going that fast to go away from the predator. So what if I increase this one? I think it's going zigzag. That is because the maximum speed is limited. So if I set the maximum speed to 0.1, oops, that's really fast. Okay, well, But at least I think it is fleeing from the red ones, I think. Let me check with the small number of points. It's a bit hard to see here. So 1,000 points and small number of predators. So let's say 1%. Okay, maybe the prey radius is a bit too high. Huh. Well, yeah, I guess it is fleeing from the predator. Now I don't see much fireworks anymore. Now if I increase this predator speed to 0.05, the same speed as prey, what would happen? Okay, seems became a better. I guess the prey radius and predator radius were a bit too high. Was a bit too high. Maybe if I set it to 0.5 and 0.5. Maybe for the prey I could increase the radius. Now the speed for both prey and predator is same, so it's hard to catch, I guess. So if I increase the predator speed by double, hopefully it will start to touches the prey. But having a bit of difficulty here. What if I increase it to 4 times faster than now? I'm not sure. Maybe predator speed is too high. I mean, make it 0.05 and make it prey speed to 0.0. Okay, now I am having a lot of collisions here. Okay, the balance is a bit difficult here, but at least it seemed to work. Now let's promote those parameters that I missing to promote inside the node controller. Another section, fireworks. Okay, and go back to the subsolver. Going inside the subsolver. And go to the gen fireworks. Okay, so first of all, attach radius. Oops, I need to uncheck this one. Touch radius. From 0 to 5. Might be too big, but maybe 0 to 1. And the pnum, what was pnum? The number of particles for the fireworks. So let's say 0 to 100. Okay, and what else? Fireworks update. So gravity force. I might not need to change this, but just in case, even to control the curvature of the trail. And max fireworks life, this is important. Max fireworks life. Max fireworks life. Okay, what else? And finally this wait a minute. Okay, I needed to copy this one, the max trail life, to this one, and for this one I need to delete the channel and set it as a new parameter. Okay, seems like a not drag and drop. Oh, it's this one. Okay, so max fireworks. Wait. Do I have this one? I don't think so. If I say apply, I say, well, I can say accept and go back to the controller again, and then go back to the subsolver again. And where was it? This one. Okay, so this one is max fireworks trail. Now that is a lot of the parameters. Which is a bit hard to control in this case. But let's see what we can do with it. Okay, now I think everything is ready here. It's a setup. We can see those particles being created, fireworks being created. Let's make the point size smaller. Let's try to see several controls. I'm going to increase the number of frames as well. 10,000, so that I can test out parameters while playing. Okay. Now let's see what I can do. If currently the max fireworks life is 20, so if I increase this to 100, I have a longer fireworks trail. If I make this value increased as well, I have much longer trail, which I don't really need. And also let's also reduce this, making it something around 30 looks fine, isn't it? And in terms of initial speed, I didn't control the initial speed for this one, I guess, but I think it's using the maximum speed value for it, so I guess fine. If I increase the value for the gravity, like set it to 0.5, you see more like particles going downward. You could also do that in a negative direction by setting it to negative, so creating upward fireworks, which is unreal but interesting. Alright, that's too much. Somewhere around 0.002 is good, I guess, or 1.5. Right, now let's also increase the number of, before doing that, let me also try out the basic swarm particle values. Like if I set the radius for the alignment to smaller, all those particles try to move independently. If I make it larger, start to create some groups. If I increase the separation radius, then try to separate really big. If I make it smaller, try to create more packed how do I say, a cluster. Same for the cohesion. If I increase this, it will create a more packed one. If I make it smaller, it will separate it. So the balance between those two values is pretty important, I guess. Also, the scale can control how much is being affected compared with other forces. Now let's try to make the separations a bit smaller so that I see a lot of packed ones. Maybe also reduce the number of alignment radius as well, so that I see a small group of clusters. Okay, now this is the maximum trail for each agent. If I increase it, I'll be able to have a long trail, which is fine, but I'm gonna reduce it to 20 for now. And predator ratio, this is for initialization, so I cannot change it while playing. The prey radius, I think I can change that. If the prey radius is high enough, then the eyesight is pretty long. So less chance to create the collisions. If it's small enough, then the prey start to lose where the predator is, so you have more collisions. So the balance between those is also important. The prey speed and predator speed ratio is also important in terms of creating the colliders. In this example, like fireworks, if I decrease the speed for the predator, I think it will create less fireworks, but doesn't seem like so. I guess it's because I have the higher radius for the searching radius for the predator. So if I decrease that, now it's lost. Alright. So yeah, controlling these is also pretty hard. Okay. But at least I know where the prey has been eaten up. Now all these seems to work okay. Now let's see if I can increase the number of points and how much performance I could get. Like if I make it 10,000, does it still move? Oops. That's a lot of fireworks. Now I guess I need to reduce the chances to create the fireworks by reducing the touch radius to 0.05. Or maybe less. Now it's not really a real time anymore, but it does still moves, and the trail might be too long, so let's make it 10. Also for the fireworks, I'm going to reduce the trail to 20. Okay. Does look like creating some kind of a school of fish. Now I want to reduce the number of radiuses for cohesion, separation, and alignment. Currently it's basically creating a circular motion. Maybe that's because the space is too small. Make it 3000. Okay. Right. And I don't see fireworks anymore. Okay, at some point. All right. Okay. Maybe I can increase the predator speed. Make it a very small. It does create some interesting circular motion here. I could play around with it, with doing several different parameters. Wow. Now it's all those particles are being moved randomly. Okay, I guess that's enough to play with the parameters. I'm not really sure what's the best point to stop this. I do want to stop at some point, maybe somewhere around here. Okay, well, right now I was playing with this sphere geometry, but I think I could use for any kind of geometry something like torus. Let's make it a bigger and see if this still works. Let's raise up the resolutions and see if this still works. Right, I think it still works. Let me increase the value for the separation. Yeah, looks good. Looks acceptable. All right, so I think it's good enough. I'm gonna finalize this by creating a switch node to switch the geometry between the sphere and the torus, or any kind of geometry you want to use. And what's this? And let's add a geometry with the changing the alpha value for this geometry that I have chosen. 0.1. Okay. That should be the final things. Okay, so it took like 3 hours to finish this, and well, unfortunately I didn't get any comments, so I'm not sure if anybody was watching this, but I would like to finish this at this point. Okay, so thank you very much if anybody is watching here. If not, well, maybe if you could join next time, that would be great, if anybody's hearing. Right, and yeah, this is working. Alrighty, so good night, and and hopefully I could do this next week. Hopefully. Yeah. So good night everybody, and good night.